A basketball player claims to make at least 83% of his free throws. Someone who has watched him play claims that he makes less than 83%. After sufficient warm-up, the player shot 10 free throws and only made 5. Is this sufficient evidence to conclude that the player makes less than 83% of free throws overall? Binomial probabilities can be used to know that the probability of an 83% free throw shooter making 5 or less free throws out of 10 is only 0.017. This is to say that if an 83% free throw shooter shot 10 free throws 1,000 times, we would expect 5 or less free throws to be made in only 17 of the 1,000 samples. While we cannot be certain, the odds are in favor of concluding the player makes less than 83% of free throws. This is a lot like a jury deciding if a defendant is guilty or not guilty. Just as a defendant is innocent until proven guilty beyond a reasonable doubt, we must give our free throw shooter the same treatment. We must assume at the beginning that the player makes at least 83% of his free throws unless the one sample we observe has such a low success rate that we can convict the player of being less than an 83% free throw shooter. But the evidence, the sample result, must convince us beyond a reasonable doubt. So, the accused, the basketball player. The accusation, he makes less than 83% of his free throws overall. The evidence, when given the opportunity to shoot 10 free throws, the accused only made 5. This is something that should only happen 1.7% of the time for an 83% free throw shooter. The conclusion, beyond a reasonable doubt, tends to be that it occurs at most 5% of the time due to random chance. 5% is 1 time in 20 samples. Since 5 or less free throws should only occur in 1.7% of samples, we state that the evidence suggests this player is less than an 83% free throw shooter. We will soon study hypothesis testing like this, but first we learn to use simulation instead of probability theory to estimate how often a particular outcome should occur. A simulation uses a simpler sample space to match the probability of the real-life situation. For example, we can model an 83% free throw shooter by rolling a 6-sided die. A 1 through 5 has an 83.33% chance of happening, pretty much 83%, so each roll of the die could represent a free throw attempted. A 1 through 5 would be a free throw made, and a 6 would be a missed free throw. We would roll the die 10 times and record how many made free throws, how many numbers 1 through 5 occurred. We would do this for maybe 50 or 100 samples known as trials and record our results and make our conclusion.